Okay, welcome back. Another week, another awesome session for hacking some Haskell on this cool game we're making called Lambda Trek. If this is your first time tuning in, welcome. I'm Agent Ultra, and this is the stream where I do functional programming in Haskell. And Lambda Trek, that's a game we're making right now. Let me show you what it looks like so far. Open up another terminal window, and I'm gonna open up my Linux one. Don't need no PowerShell up in here. Okay. Lambda Trek. It's a terminal UI based interface using the wonderful Haskell library called Brick. And this is what it looks like. Bow, bow. So right here we have our main window. This is the main interface where you interact with the game and you see kind of like what's going on. So this is going to be, we're working on the sectors right now. So it's like a local view of some stars and a couple of enemy ships. The S is your ship. The Star Trek Enterprise, we're going to go like the Lambda Trek Enterprise. I don't know. We'll make up a name for it. I don't need CBS knocking on my door. Anyways, you can enter commands like move, like flaw 3-9, say to move to the 3-9 coordinate here in our sector. Of course, there's going to be a lot more to this game. You're going to be able to jump to different quadrants, or jump to different sectors in the quadrant. And then we have like we got to have a countdown timer because the goal is to eliminate a bunch of the enemy ships before we run out of time. This is what we have so far. And I think this week we're going to talk about other game objects in our simulation here and how we can interact with them. So this is what we're going to be doing this week. So thanks for joining me. Let's get down to business and figure this all out. Okay, so Lambda Trek. We're going to go into our library here. And we're going to look at our simulations. We're going to start off with. So we have our update simulation function, dispatches handling commands. The command updates the simulation however it needs. Engine move, jump move, so on and so forth. That kind of stuff. Okay. Simulation. So, moving has to know something about the state of the sector so that it can throw an error if we try to jump into a star. It could tell the user, it's not cool, you can't jump into a star, you can't move into a star, we can't move there, Captain. Similarly, we also need to know if we're going to move into an enemy ship. Can't move into the same spot as an enemy ship. Our simulation, the way our simulation is going to work is that each tile here, rendered here, each tile of our sector can only handle one game object at a time. There's not going to be overlapping game objects in a single like unit of space of our sector here. So our player ship's going to try to move into that spot. Now, if we want to be able to handle things like moving enemy ships, which I think the original Trek game didn't do, all the Klingon ships were stationary. We may want to have like a move priority. So who gets to occupy that space first during a round, right? And I'm going to say like the player ship gets to move first and then the Klingons, if they wanted to move, or we're not going to call them Klingons, but we'll call them something else. The enemy ships, right? The enemy ships will go. And yeah, planets and stars, they could be stationary, and that'll be fine. And so you just won't be able to move in there. So we're going to check if the player can move in there first. This is going to be a little bit tricky, because if we look at the game state and how that's represented, right, we have the sector data. That's not going to be too hard for planets and stars, I don't think. So if we look at sector, we We have the list of enemy ships, the list of sector stars, which will be tuples of their positions. The enemy ships will have their positions. We could have planets as well, which could be cool. Maybe other things. But you'll notice that our tiles, what we render to the UI, right, is projected from this data. Right, so we initialize an empty set of, or an empty sector data. And we build up the sector tiles with this build sector tiles function. Right. That's what ultimately gets rendered. Right, we build up a sector tiles, and then we can render a sector tiles. So when we're checking collisions, it's not going to be as simple as like looking up into that array, into an array, unless we save these sector tiles in the sector data. Because the game state holds the sector. Right? So, what I think we should do, and we should try, is after we do our game logic, the last thing in our loop should be setting the sector tiles in the sector, and the sector data will hold it. So that when we come to the top of our dispatch and we want to move, we can check the current state of the sector, and we can just do a lookup to the tile. We could check the tile. We go from a tile, because each tile will have a unique representation, back to the thing that represents it, and we can pattern match on it. Or we can just pattern match on the tile itself. That'll be even simpler. Right? And if the tile is anything but a dot, which represents empty space, then we could just not move into it. Alright, because the alternative is then that we look through all of the sector data, like stars and enemy ships, which are lists, traversing those lists, which, granted, aren't that big. So that wouldn't be a problem, really, for this game either. So, yeah. Might not be worth actually having the extra complication of doing this, caching the tile map in the sector data. It might just be cheap, because these lists aren't going to be very huge. It might actually be simpler just to check. Does the ship collide with any stars? Does the ship collide with any enemy ships? There's two lists. They're going to be small. We might have like 3, maybe 4 stars in a sector, and like probably less than 5 enemy ships. All right. We're not really going to get into like variable sized sector sizes and quadrants and letting the user define those things. We're going to kind of fix it to a particular size. We might let them tweak the number of enemy ships to make the game a little harder, that sort of thing. But we're not going to get into like a deep simulation of a galaxy or anything like that. So like I think sector stars are going to be pretty small. So let's go with that approach. Let's go with the simpler approach. And if there is a problem, we can talk about caching the tile map in the sector data and then using that for lookups. Okay. So in order to do that then, let's go to our simulation function and handle command. Now engine move is going to be a little bit more complicated than just setting the game state of the ship. Right, we have to do some lookups and checks first. So let's we can write that here, or we can break this out to another function. Let's do it in another function. We'll go handle engine move. Game state. We can give the engine moves X and Y's directly. which we know we don't have to test if they're valid integers here, because we know from parsing the command that these values are going to be within the map, which is nice. And then we're going to return a game state. Okay. And we could just move this guy. Like that. And that should be the same thing as before. Let's get our builder going. Build fast with the file launcher going. Okay. Reload the game. It's done compiling, and that should be the same as before. So we can move 12 to invalid. Perfect. Wunderbar. So just as before. So break this out here. So now that we can check those things in the game state. So let us bind some things. Okay, we're gonna get out the sector data. Let's get the sector data, game state, sector. Okay, and we have to use that. We can dig further into the sector. Let's go to the sector. Already there. Okay, good. Okay, let's get our lenses going on this one too. Might not need just the template Haskell, I think, for now. So we can do. We're gonna need template Haskell, yeah. Okay. And then we could do fields, I think is what we've been using. Sector. We have to enable a couple of things. Functional dependencies. Flexible instances. That should be good. There we go. Yeah, so we have lenses now for that. And now we can get out the different parts. We can get out the stars. And we can get out the enemy ships. Just stars. And enemies. right. Sector star. Is that right? Oh, it's just not in scope. So let's bring that in scope. Lambda trick simulation dot sector. There we go. Okay, so we have to use stars, enemies. I don't know why it's still warning us about sector, because we kind of used it. Although, if we're not binding it, we can probably... Go there. Oh, we only need to, we can compose our lenses together, of course. We can do that. And Haskell is helpfully notifying me of this, which is awesome. Okay. Super duper. So now we have the stars and enemies. We can do our checks here before we update the game state. Otherwise, we leave the game state alone. So... we could use if condition if collides with stars X, Y, or collides with enemies X, Y, then something else. That's our happy state where we update the ship's state. In this case, we're going to return just the game state unchanged. So we just have to find collides with stars, collides with enemies in order to get this to work. And that'll take a list of couples of int, and an int, and return a bool. And same with collides with enemies. Well, slightly different type signature there, but the same general idea. List of enemy, and returning bool. Okay. For this one, we just have to, we could form this into a tuple. This is X and Y. This should be X and Y. And then we can check if this tuple is in this list with elms, or elm. So we make x and y into a tuple. We check with elms if they are part of the list of stars. And that should return true or false. Is elms not in scope? Elm. There we go. Let's pop in here. Star, sorry, thinks it's the lens. There we go. What do you call it? Stars on explore. So differentiate it from the lens, which is in the scope. Okay, for enemies, let's see. An enemy has no data yet. Let's check if it collides with it. We just return false here, ignoring our arguments until we implement that. Okay, so then we got some formatting things to fix up. So let's listen to HLint, fix those up, and get this going. Ow. S's. Put ticks on them. Okay. So this should work just as before as our game does now, because we don't have any game objects defined in our little basic map at the moment. So let's go add stars. We'll commit this. Prediction to move handler. If we detect a collision, don't move at all. We might want to add like an error message or something to like that for now, but it's good enough to get this going. So let's now add some stars. Let's see, where are we defining our basic game state? Maybe an app. No, that's just run. Okay. It's probably in the entry point to our pack game. Initial state. Initial game state. Ah, yes. Okay. Empty sector. Let us set that. Set stars to, we'll put one at 10, 10 bay. And we need lens on micro now. Okay, cool, cool. So if you're just tuning in and you don't know Haskell terribly well, or you just because you're Haskell curious or something, that's cool. This is not the usual Haskell syntax, so be aware. We usually use like the simpler syntax, but on this stream I decided to use lens library because I like lenses. They're nice. They make some things a little bit more terse, by introducing new operators. This is just a setter operator here. And for the majority of like how lens works, you only have to know a handful of them to get the most out of it. So we'll try not to go lens crazy, which you can, because some of those packages define quite a few of them. But we're gonna stay small. Okay, so that's the setter. We're gonna set the list of stars, and this is like 1 at 10, 10. So we're gonna need to render this so we can see what we're not moving into 10, 10. And that our collision detection is going. So let's just render it because it'll look nicer. So sector. All right, so when we build the sector tiles, we're only including the ship in that. So we're gonna need all the stars to set all of those as well, using our unsafe set tile function. Okay, so let's get our sector. Okay, now we're gonna need some kind of hold over our list of stars, where we're going to accumulate each of the actions into the sector map, the sector tiles, using unsafe set tile. And that's going to go like this. So first we're going to set the ship tile. We'll call it starter tile. Okay, and then we're going to do our fancy stuff here. Hold L prime, some function here. Our initial state for the fold is starter tiles. And our input is going to be the sector stars. Okay, fold L prime's probably not in scope. That's from data.list. Okay, and lens.micro, we need that. So, because it is a library-defined operator, you have to import that everywhere. But there you go. Okay. So this function here. What is the type? Sector tiles. This is the type. Tiles. Star X, star Y. We're going to unsafe set tile at X, Y to star. Negative tiles. Okay, we might not have defined that tile. So let's add it. Now we have to render it, so let's add case for that. We'll render it as a star. should be in scope. Oh, I just didn't add it there, so we'll add star here. There. Yeah, let's fire it up, check it out, see what's going on. Okay, there's our star. Right down there at 1010. If we give the move command just to jump into it, we should not move to our position, but if we move to, say, 9-9, we can move to it. We can move to 9-10. We can move to 9-11. Move to 11-10. Alright, so we can move around the star, but we can't move into it. That's good. That's part one of this, but we should display a message to the captain saying, this is no bueno. You can't move here. So that's our MVP of collisions with stars. Let's commit that. Add star tile. Also added a test star to our initial vector state. Boom. Okay. So, I think for... Let's look at the UI of our game here. So what I'm thinking we need here is, like, we have errors display here. Errors with the input commands. Right? You're looking at the command box, you input a command. I kind of look over here when I want to see the result of that command, but if there's something wrong with the command, I want to look at the command box, like what the heck happened. Because, like, if I try to, like, output coordinates, like something strange like 9,000, 9,000, that's an invalid sector coordinate. Ludonarratively speaking, not terribly interesting. Or if I format it wrong, you know, Data isn't going to turn around in his chair and be like, I can't move there, Captain. That's an invalid command. What did you say? That kind of thing. But trying to move into a star, right, it makes sense if that's a different kind of error. That could be something like Data would be like, sorry, Captain, there's a star there. Something like that. So that's more like in-game, in-universe kind of thing. And I want to display those maybe in a widget on the right-hand side in our info panel, kind of like our deep information panel. My other thought is that maybe we could have a message log widget down here for that kind of stuff. All right. So anything that, like, wants to be communicated, we could do like a chat-like interface here, where, like, somebody in our crew could tell us that that's an invalid move. You know, if we get a hail from a warship or something like that, they can display a message here. That kind of thing. And then we could reserve the right-hand panel for just the ship stats. How much energy we have, how many torpedoes we have, that sort of stuff. And so it could be like a comms box. I like that kind of thing. Like a comms box or a chat box. That'd be kind of neat. So like an invalid command could be like a chat box response, right? If we try to move into a star, we take damage, that kind of thing. We have our crewmates tell us what happened to the ship. That could make the game a little bit more, slightly more immersive, you know? It's a little flavor. Okay, so that means we need, if we're going to do this chat box thingy, we need a scrollable text widget that we can append text to. which means we got to look up documentation on Brick, the library we're using for this UI, to learn how to do scrollable widgets. Maybe they already have one pre-made, because that would probably make sense. It's a pretty common widget to have. Let's see, scrollable viewports. Text wrap widget, text wrap with. Okay. I think we're gonna have to build our own. Cropping, translation and positioning. Interesting. Okay, scrollable viewports. Render the specified widget in a named viewport with the specified type. Okay, this permits widgets to be scrolled without being scrolling aware. To make the most of viewports, the specified widget should use the visible combinator to make a visibility request. The viewport combinator will then translate the resulting rendering to make the requested region visible. In addition, the event mmonad provides primitives to scroll viewports created by this function if visible is not what you want. Okay. We're going to need some UI element for scrolling back. And so our data backing this widget is going to be like some kind of buffer that's going to have a maximum number. Maybe not a maximum number, because like I can't imagine a game generating that much data, but the scroll area itself probably should be fairly limited. So this function can automatically render vertical and horizontal scroll bars if desired. That's nice. To enable the scroll bars, wrap your call to viewport with a call to that. If you don't like the appearance, we can change it. That's great. We can change how they're drawn. That's fine too. Some caution should be advised when using this function. The viewport renders its contents anew each time the viewport is drawn. In many cases, this is prohibitively expensive, and viewports should not be used to display large contents for scrolling. This function is best used when the contents are not too large, or when the contents are large and render cacheable. Okay. We should keep the amount of data stored in the viewport scrollable buffer of a limited size. For gameplay purposes and stuff, it might be fun to keep all of the whole scroll history so that for some reason if you want to analyze your save, you can. That kind of thing. But I have no real plans for like doing save game stuff, so we'll see how that goes. Okay, so I guess we can add, we could just make it a text widget and add it inside this viewport, I suppose. Okay. So we give it a name, the type of a viewport, and the widget to be rendered in the scrollable viewport. The N has to be the same. Okay. Okie doke. Let's try it. Let's see where we get with this. Okay. So we're gonna go to UI. Over here. Info panel, our command palette, and our sim display. So our dialog box thing is going to be part of our sim display, I guess. So this is where the sector rendering is happening at the moment. All right. And this sim display is going to get a little bit more action later on because it's going to have to check what kind of state we're in order to dispatch to the right UI. Because we're also going to be displaying the warp, like when you go to the like the warp screen or whatever it is, what we're going to call it, where you jump to different sectors. That's going to display a different UI entirely in there. So yeah, it's fine for now. We can even pull it out and call it sector display. It's not gonna need the whole form thing, just a game state. Oh, maybe it does need a name because the name has to be returned there. Maybe that's fine. I think we'll find out in a moment. Okay, sector display. We're gonna just take all this. I'm gonna go pop it up here. And then we're going to call sector display with the passing in the form state of F. And we can just chop all this out. And then we don't need this. We can rewrite this as being state sector. We can rewrite this as game state ship. Okay, we gotta import those things. Lambda track. No, it's lambda track state there. Yeah. What's the type error then? Oh. Is it because I named it like this? That's probably why. I messed up something with the naming of the field. Or maybe I used the wrong template Haskell constructor function thingy. Anyways, that's good. So we can read it like that. And the game should work just as before. Perfect. Okay, so we have our sector display there now, and now we can add our widget to the sector display. We can add our dialog box. Maybe we're going to define that separately. So we would do it there, and I think the vertical one is this. That compiles, and if we run it, I am dialog. Very good. Although I kind of want a border around it. Limit, okay. Look, so we can limit the height. Join borders. And as wide as possible. I'll start a new function for us, sector dialog. Doke. Good, so then we can do join borders with border style. Yeah, with border style, join border, something like that. See how that goes. Oh, that had no borders. Do-do-do-do. Okay. Command palette rendering. Oh, I see. We put an explicit H border widget in between the two. We could probably do the same thing for that. For our sector dialog. That's kind of what I'm going after here. Let's go there. That's a little better. Okay. Cool. So we can limit that to a certain number of rows and then make it scrollable. That's, I think, is sufficient. So I think it's vlimit. Or vlimit percent. Because if we make it a percent, then yeah, we lose it there. Alright, which would be a gameplay fail. We'd have to set like a minimum. Okay, so we set the available size, height, and width. Limit space available to the specified widgets. So like a minimum? Okay, there might not be, in which case we should probably have something for that at some point. If you can't see the dialogue, you're going to miss out on important things, but it looks like we can query the viewability of a widget. Okay, we might even be able to use this visibility thing of viewports to do that, to force it to be rendered, but it might like render over the map. So we might want some minimum height thing and width thing for our UI to render for the game, just to prevent that from happening. So we should hopefully have some way of doing that. But let's focus on our dialog box for now. So we got that. Let's just tweak it a little bit so it's got the height. Okay, vlimit. Let's try vlimit, see how that works. Vlimit, let's say like 5 rows of dialogue would probably be enough. So now it's static, could shrink. Grow. Actually, it's growing. It looks like it's growing to more than 5. Ooh, I closed the whole terminal. Silly me. Merp. Okay, so that's not holding us down at 5 exactly. Eliminate to 5. Well, why it wouldn't matter if we move this out here. Oh, maybe it's the H border. Right, exact Lambda truck. Yeah, maybe it's the H border that's doing it. I'm not paying attention to what I'm doing. There we go. Shrinking down is fine, but when I'm growing it like this with the V limit, I expect this not to be more than 5. But obviously we're getting quite a bit more than that. It's not the worst. If I put the V limit 5 over these ones. Put them together. No, I don't think that's... It's not working either. The V limit. Why isn't the V limit working? Okay, let's see. No, no. Okay, well, I'm not going to worry about it too much. We'll leave it for now. Try to figure it out later. I'll put the V limit back in there just so that I know it's there. And that's what I want. Even though it's not working. We'll leave a little to-do note. Figure out why V limit isn't actually working. Okay. So let's work on scrolling. So I saw there while we're bouncing around some of these like with these scroll bars, which just needs an orientation and a widget, which is super cool. On right. That's capital B. There. Nothing to scroll yet, but if we added a bunch of new lines, what do we get? Oh, it is being limited to 5. Just for some reason, it's taking up more than I would like. I like how I did it with the command palette on the right. Although our vertical scroll bars aren't showing. Should get one right about there. Okay. On that? Try that. No, I'm still okay, so we have to do something to render them? Okay, looks like we do. Okay, so we have to, what do we have to do? Call vertical scroll bar renderer? So we enable them, okay. Oh, we gotta wrap it in a viewport. Yeah, I guess. I guess we gotta put it in a viewport. The viewport type. Vertical. And we gotta construct a name. Name. I don't know what to put there. Command field. Ooh. There we are. There we are. Let's create a new one. Or we're gonna make a pipe. We're gonna make it, sorry, a pipe. We can make it a sum type. That's what I meant. So instead of command field, we can do sector dialog. Cool. Okay, still not getting a scroll bar. Okay, so we've got a viewport, a sector dialog, with these scroll bars. What else are what are we missing here? What do we got to do to get this going? Let's see. Yeah. Visible. Oh, maybe we gotta make it smaller. Hang on. Still no. And though we have way more content in this, so there should be a scroll bar displaying somewhere here. What's going on? Take out the elite limit. Okay, we get way more dialogue. That's good, but no scroll bar. So that's no good. Let's also push it down to the bottom, like we do with command palette. H limit %. No, that's not it. Info panel, H border, command palette. Yeah, it's V limit 3. Info panel is just the string right. No. Not how I like it. Okay, give him a scroll bar. Let's see if we can find an example of using this here. Brick. Oh, there was some better documentation. Brick documentation. Yes, the guide. Showing scroll bars. To enable scroll bars, wrap your call to viewport with a call to. Oh, okay. Well, that would be good to know. So we wrap our text with viewport and then call with these scroll bars on the viewport. Okay. Like this. Ah. All right, sweet. Let's put it on the right. Sweet. Can't scroll it yet or anything, but it's there, which is good to know. Now if we could just make it only take up 5 and and push this down more so that it's at the bottom like the command palette, then we're set. We're golden. And then we just have to set up our buffer backing this text and then create a renderer for it. And yeah, and then figure out how to feed data into it. Right? I'm getting some ideas brewing already in the old noggin for that. Okay, so vlimit 5. This is the part that's bugging us here. Take that out. So put the vlimit 5 around this whole schnazzy bit here. Oh. Okay, not around the border. Oh, I guess I have to put parentheses parens. Like that. Yeah. And then I don't need a parenthesis. Okay. So, well, we got something going there. It's not quite the alignment I'd like, but we're good. Okay. Okay, so we'll tweak alignment later. It's good enough-ish for now to like at least poke around with it and get the functionality working. So let's empty out this text and create our backing data structure for it. Okay, let's commit this. Add sector dialog widget. Oh, excuse me. Okay, so then let's go to the game state. Sorry, 2.2. That's fine. Our game state definitions up here. Game state dialog. Yeah, that's good. We'll make it a list for now of dialogue. Okay, so here's what I'm thinking as we're discussing this widget and stuff and what's going to go in it, right? Little narrative things. So if there's something like in-game that somebody wants to communicate to us, I think we should have it come in the form of dialogue from the different crew members to like kind of add a little bit of immersion to the game. So if we're talking about the move command right now, because that's what we're implementing, then our helmsperson should be emitting the dialogue. All right. And when they emit the dialogue, we want to know what comes from the helmsperson so that we can render it slightly differently. So you can see like the helms message, you can see a message from security or whatever. And that'll just kind of like spruce things up a bit. So let's go define dialogue in the simulation. Lambda trek simulation dialogue. It's gonna be a relatively simple module. So we're gonna have like who the dialogue is from. So we'll call it crewmate. Now we'll have help for now, because we're only implementing it at the moment. We'll drive our usual type classes for it. In fact, we might even want to move that to a whole thing. Leave it here for now. And so we'll have dialogue the crewmate and the text they want to say. Super duper. Okay, what's our build error? We don't have dialogue imported yet into the game state. That's cool. Let's import it. So I'm thinking of this kind of like a little bit like Disco Elysium. The different parts of the brain can talk to you in kind of like a Twitter feed. Similarly, dialogue can come from different parts of your crew. I can tell you different things about what's going on in the game. So we're going to need ord on this as well. And there's going to be need those. So they can be part of the game state. Okay. So then we need to render the dialogue to text. Or we might want to actually take advantage of Brick's rendering capabilities to render different colored text for different parts of this. Because that'll just make it easier visually to pick up. So this probably should be actually a widget. Or we gotta put this render function... Yeah. Put the render function for this in the UI. Cool. So we'll call it a dialogue. Which name? A dialogue widget name. Let's import that. Dialogue and dialogue. And yeah, we just need dialogue. We'll need everything. And nothing flashes, so we don't need to before it qualified. Oh, I left the qualify on there. Sorry. Meh. There we go. Okay, okay. So let's explode out the dialogue. We'll get the crewmate and the message. Key. And then let's see. When we render the error, yeah, with this attribute stuff that does all coloring. So we're gonna have to add coloring attributes for the different crewmate types, I guess, into our attribute map. Okay, so we will first render and can we sorry, for text widgets I want to know if I can just combine them together monoidally so I can render different parts in different colors. So I could just render the crewmate part in one color, but the regular text is just the regular terminal color. That would be cool. Probably with wrap. Okay, maybe just with this combinator we can do it. Alright, so first we have I'm gonna do it like a little arrow. And then we do that. And then we're gonna render something in here. And then we have text wrap. Okay, and then we just have this hold use crewmate. So use with outer name, and then we'll do outer name from crewmate. And we want to do text wrap. And we'll do like this text wrap and true text for the crewmate. Yeah. I'll put it here for now. Like this, but I'm going to change it up in a minute. Once we got this working. Crewmate. From crew. So we're going to do a pattern match here on the crew type. We just have helm right now, I think. Call it highlight helm. And then crewmate text. Also Lambda case. I will like render them uppercase, like no. Also colored. With like a colon. So that's TXT. So I probably need, what do I need? Car. Okay. Oh, I need overloaded strings probably. Overloaded string. Close. Okay, so now we have that set up. We should be able to get the list of dialogue out, render a bunch of them into this viewport. If we could do that. Otherwise, I'm going to have to think of a different way of doing this. Maybe with vterms built-in stuff for text coloring. What are we going to do? How are we going to do this? We are going to do this as... We're going to get the game state first as an argument. And let me get the game state here. Okay, and then we're going to join together a bunch of dialogues vertically, a bunch of dialogue widgets vertically from the list of dialogues. So I'm going to combine these to a bunch of compositions. And we're gonna have a function here. No. We might be able to do this with fold. dialogues. I'll call it. And we will give the game state. What did I call it? Sector dialogues? Just dialogue. Okay. Combine dialogues. Let's just put in the type like this. Just a handy dandy little way of asking GHC what the type ought to be, so we can just plop that in there for good old documentation purposes. Alright, set it to undefined. It's getting mad at me now. Okay, we're missing something over here. Sweet. Yeah, okay. That's should be fine. Let's just write in the type where we ought to know it to be. That trick isn't working right now. No, it doesn't think it's... did I? Yeah, it's the main thing again. Oh, and some H-lint help. Okay, what did I do now? Stir... Oh, it just wants me to move the parentheses around to avoid the $sign. Okay, fine. Fine. Just do what the linter says. Okay, so to combine the dialogues together now into these widgets, we're going to combine them vertically. And we'll try it with a bolt first. Let's see what happens. That'll be our function. The initial state of the empty widget. And combine that with dialogue. Oh, I also named the function dialogue. Hilarious. Bold L is not in scope. Let's bring it in scope. Import data.lists. Bold L brand. Right. this isn't going to work here. I was thinking we would reduce this down to a widget from the empty widget by combining together with this combinator. What if we map those to a bunch of widgets? And then we combine those down all vertically with that and the empty widget. Okay, that might work. Okay, compiles at least. It's not going to render anything yet. Let's... Runtime error there. Super fun. Our initial game state needs to have some initial dialogue, so let's go ahead and add one for testing purposes. And a dialogue from Helm. Woohoo! Nice. We haven't defined the color attribute yet to render for rendering the Helm part of it, but the text is there, which is cool. I want it to be left aligned internally in there. So, maybe? No, it's probably not left. It's probably like justified or something. Align left. Where did center come from? Can we turn off centering just... Maybe we have to be a little bit more careful about the centering. left. No, let's take that out. Not quite, but almost. It's getting a little better. Let's see, huh? What did I do? I clearly misunderstood that H-lint suggestion. I think what it wants me to do is move these parentheses around here. Okay. Well, alignment we'll fix in a minute. Let's get the coloring going. So I think we're running a little low on time. So our attribute map, where do we create that? There we go. Then the app. Okay. Let's bring that over to the left because we're going to add a few more elements. This. Pattern name. Highlight. Helm. G. V.yellow. Let's do that. Highlighting. Sweet. Okay. Let's take a few more minutes to see if we can fix the alignment thing, and that looks good. Let's try, like, maybe adding one more line, or a few more lines to our initial state. Yes. 3, 4, 5, 6. It's looking good. Looking good. Oh, now that it's not text and it's widgets, it's actually rendering properly. That's probably what it was. It just didn't know the size of the text, really. And what I mean is that before, I think before it was only rendering like a little single scroll element up there, so Now it knows that there's multiple elements. That's good. That's really good. Okay, so now we just have to override the alignment thing here. It's still centering everything as much as possible. So we want this widget to be aligned to the left, no centering. Align left 0, maybe? That's, it looks like it's table type stuff. Hint table, table. I think maybe the approach is just to be more selective about where we put that center. So sector display. Command palette is using it. Info panel is using it. So why is the dialogues doing it? So I can justify. Left. Align. That's all table stuff. If I take the center off of that altogether, what happens then? No, it just gets worse. Because we're combining those as widgets, maybe what? They're trying to take up as much horizontal space as possible evenly. Right. Maybe what we need to do is like tell Brick to give as like no padding, just shove them right next to each other. Maybe that's what we need to do. Not handling app events, yeah, not yet for that. I think that might have something to do with it. Though. So there might be a smarter way of doing this instead of using widgets to combine the dialogue together to actually just render the text using the VTY package and just doing it that way. Might be easier, might be a little bit less load on Brick to figure this out. Okay, yeah, we can set padding. Maybe we can set padding to do it. The other thing I was thinking is if Brick's widget type has a monoid instance that combines them, which doesn't look like it does. Yeah, extend visibility, borders, miscellaneous size, direction, and some lenses, things like that. Okay. Okay, well, let's try the padding, and if that doesn't work, then we're gonna have to call it a night, and I'll look into maybe using the VTY package just to render a text string, and then we just have it as one string and not a bunch of widgets combined together horizontally, and then we don't have to deal with the layout flow and stuff like that. So, oh, growth policy, interesting. I wonder how we set those. Pad left, pad right. Let's set the pad right on the widget here. Padding, oh, padding. Pad int, okay. right. Like that. Booyah. Maybe we need to force a rebuild here. No. Okay. 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 Still should rent them out as individual nodes. I think we're just making this combined 3 widget thing is just we're mucking with layout stuff. So if we can render this colored text in there just using raw VTY codes, then that will be better, and then we don't have to worry about this. We'll set our own text justification and stuff. But yeah, there you go. So that's cool. We got a vertical scroll area for our dialogue. We kind of got the basics of a dialogue system going. And we implemented collision detection and stuff with our stars. So the next stream and the next part of it, we're going to move on to this command here. If we try to move 1010 into that star, where instead of displaying it as an error, we're going to display it as dialogue from Helm, saying that I can't move into a star, Captain, that kind of thing. And that'll be cool. We'll get the rendering of that all figured out, and then we can have some event handling, so we can scroll back through this buffer of dialogue, and do all of that. So, thanks for joining me this week on the stream and watching and following along. Let's get all this code pushed up, and I'll tell you a little bit about this project and a little bit of my stream. So, let's just do a quick there. Add dialogue and dialogue widget under cool dialogue to the sector dialogue box. Yeah, so that's what we did tonight. Let's push it up. Good night's work. All the code for this project that you've seen tonight is on the GitHub. I'm Agent Ultra. This is my GitHub here. The code is at Lambda Trek. Agent Ultra / Lambda Trek. That's this project here. I am also on the socials, on the Mastodons, on the types.pl server. You can find me. I'm Agent Ultra there. And of course here. If you'd just like to subscribe to this stream and get all the notifications and all that on the Twitches, you do that here. If you're watching from a different time zone on my YouTube channel, you know what to do there as well. Subscribe, like, and all that stuff. Really helps. And yeah. Thanks for tuning in. Go to declarative.tv. You will find the Discord server. And you can join the Discord server and chat with us there on the channel for this stream. As well as other cool declarative and / functional programming people who do streams in other languages, including Haskell. So if you want to check that out, go up there and follow along. Thanks again. I'm Agent Ultra. May your monads be free, and may your types always check. See you next week on Tuesdays at 8 o'clock, roughly. Bye.